Okay, so today I'm going over operations on polynomials, which is section 2.2 in the textbook. This is related to the third assignment that you guys have in ALEX. You may have noticed that we renamed the assignments and at least tried to put the number on what order you should do them to hopefully eliminate any confusion. So hopefully that is clear. So hopefully you're getting used to the system, used to using the ebook, finding my videos, the videos from the ebook and all that kind of stuff. So this should help you prepare you to do that third assignment. And then that fourth assignment then is factoring. So, oh, thank you. I heard it echo. I'm like, oh, wait. So you're welcome to unmute yourself when you have a question. But yeah, keep yourself muted so we don't get any feedback. So we want to start with basically what a polynomial is, because that's what we're working with for the third assignment and the fourth assignment. So just a little bit of history if you're curious. The first instance that we have found of the word polynomial was in 1674 in I'm assuming that is a book. I didn't actually look to see whether it's a book or what it is, but Arithmetic by Samuel Jake. I'm assuming that's how you pronounce it. But he says, and those knit together by both signs are called by some multinomials or polynomials. That is many named. This is actually, if you break down the word polynomial, poly means many I believe it's in Greek. It comes from a Greek word. And then nomial is actually related to Latin. The word in Latin for name is nomen. So that's where nomial sort of comes from. So it's sort of like a combination of a Greek and a Latin, combining two words from different languages together, and that's how we come up with polynomials. Essentially what the definition is when this first showed up in the 1600s is that it's just we're combining multiple terms of things with a plus or a minus in between them. And we do have specific rules on what is considered a polynomial. We can't just add any old thing together. But in general, if you have a series of terms added together with a plus or minus in between each term, then that is a polynomial. So if we look at it more in a mathematical standpoint versus looking at the language and vocabulary, a polynomial, if we have the variable x, is a finite sum of terms. So finite just means that there's a set number of terms. It doesn't go on forever. And it's in the form ax to the n. So that form just means that you have a series of terms that may have a number in front, which is a, and they may have an exponent on the variable, which is x. So our general form, this is a very mathy form of a polynomial, is a sub n. So these lowercase numbers, these are all subscripts, which we use as labels. So if you've never seen that before, we are just labeling the variables, basically just numbering them so that we know that, okay, we have an a, which is some number, and then we have a certain number of them, and we just started counting at 0 on the right, and then we're counting up as we go to the left. So these are just labels, just different ways to keep track of the variables that we have in here. So you're just adding things together that have exponents. The key of a polynomial is that there's no variables in a denominator of fractions. You can have fractions, but the variables are not in the bottom. There are no variables inside square roots or absolute values. And there are no negative exponents on variables, or there's no rational exponents on variables. So there's no decimal exponents or fraction exponents. Those are the general rules for a polynomial. So an example would be 5x to the fourth plus, let's say, 2x squared minus 5. So we've got different terms that are separated by pluses and minuses. So we have 3 different terms here. And generally, if you were asked to identify parts of a polynomial, we include the negative sign. So what I recommend that I think is a little easier for a lot of people is turn any negatives into plus a negative. So subtraction is the same as adding a negative. Because when we identify parts of a polynomial, we include any negatives or minus signs when we're identifying them. So we've got variables. There's no fractions here. I could make one of these a fraction. So let's say I made this first one. Let's say this was 5/2. The variable there is not in the denominator, so that still makes it a polynomial. We don't have any variables inside square roots or absolute values. We don't have any negative exponents. We don't have any rational exponents. If you just joined, please mute yourself so we don't have any feedback in the recording. And you can unmute yourself when you're ready to ask a question. Thank you. So this is the form of a polynomial, basically. And you can have lots of terms. Here we have 3 terms because they're separated by, and in this case, pluses. And so that you just highlight everything, and then that can help you identify how many terms you have. Are there any questions so far? All right. We're going to continue breaking down the language here because it's important to, like, we know that math is a language, and it's all about understanding what do these words mean, the terminology, the definitions, because they'll help you kind of figure things out going forward. So moving on to specific terminologies that we use with polynomials. So each of those terms that I mentioned, those, again, I'm just saying that those are terms. And we have this AIXI. I is just an index. So it's just saying, okay, I could have an exponent of 2. So then my coefficient would just be labeled the second coefficient to go with the exponent of 2. Those are just ways to kind of keep track and a general way of indicating all of the terms without having to list them all. If you're in computer science or you have to do some programming, you may be familiar with using I to count through things. So it's the same sort of concept. It's just a way that you can cycle through and just count. So we have lots of terms. If you have only one term, then it is a monomial. So mono, I don't remember if this is Greek or Latin, but that means one. That's where we got a monocle, which has one eyeglass. With religions, you got monotheism. Is it monotheism? I think is how it's pronounced, but that's where you believe in one God. Mono comes from one. So an example of a monomial is literally just a number, because we have one term, and a polynomial could be something with no variables. So that's an example of a monomial. But you could also have something that has like a variable, like 3x squared. So it's just one term. You don't have any plus or minuses in there. So that's what makes it a monomial. If we have 2 terms, that's a binomial, and that bi part means 2. So if you've got a bicycle, it has 2 wheels. If you talk about perpendicular bisectors, if you have to do any, like if you're woodworking or something like that, you're putting things into 2 parts, you're bisecting it. Biannual generally means every 2 years, not to be confused with semi-annual, which is twice a year, but bi generally means 2. So a binomial has 2 terms. So I could combine those 2 monomials to make a binomial by adding them together. So if I add those together, I now have a binomial. If you have 3 terms, then it's a trinomial. Tri is 3, like tricycle. So I could have those 2 terms, and then let's say I add on minus x cubed. So now I have 3 terms because I have 2 symbols, a plus and a minus, and that makes it a trinomial. Anything larger than 3 terms, we don't have a special name. And the reason why we have special names for the 1, 2, and 3 terms is because those are the ones that you see most often. And so understanding that language, especially binomial and trinomial, that's really important. You're probably not going to see monomial so much, but you will see the term binomial and trinomial as we move forward. So knowing what those mean is going to be really important, so that way you know what your directions are. You can look at something and say, this is a polynomial. Here are the things I do to polynomials. Okay, this polynomial is a trinomial. Here's what I do with trinomials. So understanding that language can help you kind of categorize your notes and then look in your notes for the right piece so that you know what to do with it. Are there any questions so far? All right. So next we have degree. So we're going to talk about a degree of a polynomial. So first we're going to look at each term. So those are the things separated by pluses and minuses. So the degree of a specific term is the sum of the exponents on the variables. So if I have 2x squared plus 3x cubed y to the 4th, and I can have polynomials with more than one variable, that's okay. So if I look at this, I have 2 terms. I have 2x squared and I have 3x cubed y to the 4th. So the degree of each of these is the sum of the exponents on the variables. So the first term is x squared, so that is degree 2. The second term, I would add those exponents and get degree 7. Because 3 plus 4 is 7. If you have a variable that has no exponent on it, you assume it's an exponent of 1. So when you're adding the things together, you add it as a 1. And if you have something with no variables, then it is considered degree 0. So an example of something that is degree 1 would be 2x. So there's no variable on that x, so we assume it's 1. Something that's degree 0 would be just a number 2. So it's basically your degree is counting how many times how many variables you have in there if you were to expand them out. Now, when you have a polynomial, you have also, in addition to the degree for each term or each part of the polynomial, you also have a degree for the entire thing, and that is the highest degree out of every term. So the example that I have here is degree 7 for polynomial, because the highest term has a degree, or the highest degree out of each term is 7. So the whole thing is considered a degree 7 polynomial. Understanding the degree of a polynomial is really important because we are specifically going to be spending a lot of time on degree 2 polynomials, which are called quadratics. So we have a special name for those. Those are called quadratics. So knowing that terminology is really important there. And then last, we usually write polynomials so that you're counting down your degrees, so that the highest degree is first, and then you count down as you move to the right. And when you write it that way, it's called standard form. So my example polynomial here, if I put this in standard form, would be 3x cubed y to the 4th plus 2x squared, so that I put that highest degree first and then I count down. Are there questions? Okay. Now, coefficients. So the values in front of the variables, the a's that we have in our general mathy form, are called coefficients. So the numbers that are in front of each variable are called coefficients. And unfortunately, I do not know how this word breaks down. I know some of the other terms. I took Latin, so I can usually break them down and figure out, oh, what does this mean? But coefficient is one that I don't know how it got called that. But it's called a coefficient, what's in front of the variable. And so the highest, the number that's in front of the highest term is called the leading coefficient. And then that highest term is called the leading term. So if I have 3x to the fourth minus 4x as my polynomial, and this is a binomial because there's two terms, the leading coefficient would be 3. Because that is the one that's in front of the highest degree, that has the highest exponent there. If you were to list all of the coefficients, we have two coefficients. We have 3 and then -4, because any minus sign is considered when we look at the term or we look at the coefficient. So that is considered a -4, a -4 coefficient. So you can always put a plus in between the subtraction so that you can see that better. Then our leading term is this first term with the highest exponent, the highest degree. And it's leading because it's in front when we write these. So that's what makes it the leading term. It's leading the rest of them. So some vocabulary there. I was like, what word am I looking for? Any questions on this terminology here? All right. Now let's actually move on to the operations. So operations, if you see the word operations, that's arithmetic, plus, minus, multiplying, dividing. It could involve exponents because exponents are repeated multiplication. So those are considered operations. So when we say we're doing operations on polynomials, we're adding, subtracting, multiplying, dividing. But with polynomials, there's also another one called factoring. So adding and subtracting are literally just adding like terms, combining like terms. So it's the same thing when you're told to simplify an expression. Oops, I'm in highlight mode. So if you see the directions simplify, where you're told to simplify an expression, which is something that we did last week, you had to simplify expressions in the second assignment for last week. That was combining like terms, so that's the same thing we're doing here when we're adding subtracted polynomials. In fact, what you were working with last week were polynomials, you just didn't know it. You weren't told that terminology. Next, after adding and subtracting, we have multiplication. So when we multiply polynomials, there's different techniques. There's FOIL. There's distributing, which you did learn about distributing. We were distributing last week with numbers. Here we're going to be distributing with variables as well. But those are some techniques for multiplying. Next is dividing. We can do long division on polynomials and something called synthetic division. You are not going to have to worry about those right now. Those are going to come up later in the term. So don't worry about doing that kind of stuff yet. And then we have factoring, which is basically reversing or undoing the multiplication process. And that is going to be, that's the assignment after this one. So division is the only thing you don't have to worry about this week. It will show up later, but you're going to be adding, subtracting, multiplying, and then factoring, which is undoing multiplication. So I'm going to go through all of these different examples, showing you how to do these things. So we're going to actually kind of get into some math here. So if you are told to add or subtract a polynomial, sometimes you're not told to add or subtract. They use the terminology combine. But that literally means that you're adding or subtracting. So we have words that mean the same sort of thing, so we're combining. These are put in parentheses to indicate that you have two polynomials you are combining together, but you could, if it's a plus and there's no number in front of the parenthesis, you could ignore the parentheses altogether. So the first set of parentheses with my example on the left, I don't have a number in front, so I can ignore the parenthesis. So I'm going to just rewrite it. And then I have a plus. And then because I don't have a number in front of the parenthesis and it's a plus, I can ignore the next parentheses and just rewrite what I have. So the only reason those parentheses are there to make you see that we have two polynomials, but that's literally just, you can just write it all out without the parentheses, and then you are combining like terms. So I like to work with some highlighting when you're first learning these things so that you can make sure you have your like terms. So like terms need to have the same variables and the same exponents on those variables. And because we usually put polynomials with the highest exponent first, we will try to combine those first. So I have an x to the fifth, so I'm going to highlight that. So I have a negative 9x to the fifth, and then a negative 13x to the fifth. So when I combine those, I'm literally adding the numbers together. I have a negative 9 plus negative 13. So if you just want to make sure you don't make any arithmetic mistakes, you can just use your calculator for that. And those add to a negative 22. So I'm going to write this, negative 22x to the fifth. Now I'm going to go down to the next exponent that I have as a countdown. So I have an exponent of 5, and then I look, do I have any with a 4? No. So then I'm like, okay, well now I'm going to count down to 3. So I have two things with an exponent of 3. I have, oops, that was not the highlighter. Here we go, 12x cubed. And then that minus sign that is considered, we use it with the number. So the minus signs always go with the number. So that's a negative 6x cubed. So when you combine these, you're looking at 12 minus 6, because we're going left to right. 12 minus 6. And that gives you 6. So that's a positive 6. Oh, I'm going to go back to my red. So I have plus 6x cubed. So notice that when I combine these, I'm not doing anything to the exponents. We don't mess with the exponents when we're adding or subtracting. So those are all staying the same. It's like in the video where you're adding, you know, like apples together. I have 12 apples minus 6 apples. You've got 6 apples. So that x cubed, it's just language. It's just another word. So we don't mess with it. So now I've got an exponent of 5. My next one was 3. So then I look, do I have anything with an x squared? I don't. So now I look for, do I have anything with x? So I do have something with an x, but I don't have anything to match it up with because there's only one thing with x. So then I just write what I have. So that minus sign in front of the 4 says minus 4x. So I'm going to write minus 4x. And then I look at, finally, the last thing you look at is the actual number without any variables. So that's a minus 6. So then you write minus 6. And there's nothing to combine that with. So once you've combined everything together, now we have a polynomial, and now we have done what we were asked. We combined the polynomials together. So here we have 4 terms. So this doesn't have a special name, and it's a degree 5 because 5 is the highest exponent. So we're not solving. The only thing we can do is combine. So we're trying to add things as much together as we can. And then once we've added everything together, we stop because we have nothing more to do. You're following the order of operations. And the last step on the order of operations is addition and subtraction. So once you finish those, you have nothing more to do. So you're done. Are there any questions on that example? Okay, so now I'm going to move to the one on the right. We have a polynomial 9x to the 5th plus 13x to the 4th plus x minus 9x squared minus 3x to the 4th. So whenever we're subtracting and you have parentheses, you always have to distribute and treat that like a -1. So we did that when you had to do some stuff with distributing with the order of operations. So I'm actually going to rewrite this. So first, the first polynomial, I don't have a number in front of the parentheses. So I can just write 9x to the 5th plus 13x to the 4th plus x without the parentheses. But now I have that minus, which I'm going to write as adding a -1, and then I still have my polynomial 9x squared minus 3x to the 4th. Because whenever you're subtracting polynomials, you basically have to multiply that negative sign through the parentheses. So we're going to be distributing by multiplying -1 by each of these numbers. And because I have that -3, you can treat that as plus a -3. So you're multiplying a -1 by -3 there. So we're following the order of operations. Whenever you're simplifying or combining, you're following the order of operations. So we have to multiply before we add things together. So the things that I am not multiplying, I'm just going to rewrite. So I have 9x to the 5th plus 13x to the 4th plus x. Now I need to multiply my -1 through the parentheses. So -1 times 9 gives me a -9. And then the x squared just kind of hangs out. So it's -9x squared. Then I have a -1 times a -3. Negatives cancel, you get a +3, and then we have x to the 4th. Now that all the multiplication is done, now you move on to addition and subtraction. So now we're looking for our like terms. So again, just like on the left, I'm going to start at the highest exponent and work my way down. So the highest exponent is x to the 5th. And I don't have anything else. There's only one thing with x to the 5th, which is the 9x to the 5th. So I'm going to just rewrite that. The next exponent would be 4. So I do have two things that have an exponent of 4. 13x to the 4th plus 3x to the 4th. So I add those together. 13 plus 3 is 16. So this gives me 16x to the 4th. And then I'm counting down. Do I have anything with x to the 3rd? And I don't. So then I go, do I have anything x squared? And there's only one thing that's x squared. So I can just write that -9x squared. Then I go down to x. Do I have anything with x? Well, there's only one thing with x, and that's plus x. And then I don't have any single numbers, so I don't have anything else. And I've combined everything together. And then because all of the exponents are different here, I can't combine them. So that is my final answer. That's as far as I can combine these things together. Are there any questions? Yes, Tim, go ahead.
Yes. So when we always struggle with that part of the minus and then making it into a -1. So if there's anything inside the parentheses after we change it to a -1, we should change everything to plus negative or plus positive, correct?
Yes.
Okay.
And I recommend this because a lot of people struggle with negative signs, and doing this helps eliminate some of that error. Because I often see people that don't do that tend to get sign errors. Generally, because I've been doing math long enough that I don't do that when I'm doing my own work. But for you guys, for sure, I would recommend that you do that so that you can make sure you get your signs correct.
Yeah, because I always would do the keep change, but I would always only take care of the first term and forget to do it all the way through.
Exactly. Yes. And that's another reason why I write arrows there, to kind of remind me that everything is getting changed, not just the first thing. Are there other questions? Okay, so I'm going to do a couple more examples, and notice I'm changing the directions here, and I'm doing this specifically because in math we have a lot of directions that mean the same thing. So the previous slide it said combine the polynomials, which we're saying adding, subtracting. Here it's not giving anything, not telling us it's polynomials. All it says is simplify. But that still means that we're going to be adding and subtracting. We are still combining like terms. And we're still going to follow the order of operations. So it's the same thing, it's just more terminology. And most of the time, it would help if I spell operations right. Can't spell and operations, spell and talk at the same time. Most of the time, you'll see the word simplify because it's a lot easier to write one word than to write all of this stuff. So if you see simplify, these are the various things that it is telling you to do. That you're going to be combining like terms, you're following the order of operations as much as possible. So if you have to multiply first, you multiply. Then you add things together. So that's the key, is knowing one, it says simplify, what that means. So these two examples are much more complicated because I've added multiple variables here. And I did this because that's usually when people get confused on what like terms are. It's one thing if you have one variable, it's pretty easy, but if you have a combination of variables, that's where it starts to get a little confusing. So I'm going to start with the example on the left, and this is another addition one, so if it's pure addition, you can ignore those parentheses. So I'm going to just write it without the parentheses. So when we were looking for like terms, we need to have the same variables. So that if it has an x and a y, then a like term also has an x and a y. They also have the same exponents. So, and I said that we usually go from the highest exponent to the lowest. Well, we've got multiple exponents here, so it might be helpful to kind of figure out the degree of each term so we know what we're looking at. So the degree, you're adding the exponents together. So our first term has degree 5. Second term is degree 6. Then we have another degree 5 and then another degree 6. So we're going to start with the higher degrees. And then when you have multiple variables, we usually go alphabetical order with the highest number. So these are all conventions. We don't have to do it this way, but this is the way that we generally have. There's just like a, general rules that you follow so that everybody's sort of on the same page. Like with English, you could talk like Yoda or you can talk like normal. I mean, they both say the same thing. There's just a general convention of what order you're supposed to do things. So the convention here is that you have the highest degree, you do those first, and then when you have things with matching degree, you look at the variables, you go in alphabetical order from the highest degree. So we have two things that have degree 6. One of them has an x to the 4th, one has an x squared. So the x to the 4th is going to come first because it has the highest exponent out of those. We're just ignoring the y's. We're just going to go with the x's there. So these are not like terms because the variables on the x are not the same. So I don't even need to look at the 5th degree because if it's a like term, it's going to also have the same degree. So I have to look at things with the same degree, and then if the exponents don't match, they're not like terms. So I don't have any like terms there, but I want to write it from the highest degree to the lowest. So I'm going to put my 16x to the 4th y squared first. because the x has the highest exponent. And then the next one will be the 6x squared y to the 4th. So I couldn't add those because the exponents are different. So I'm just writing them down. Next, we're going to go with the next set of degrees, the degree 5s. So we have a 4x cubed y squared. Then we have a minus 5x squared y cubed. So again, those are not like terms because the exponents don't match. One has an x cubed, one has an x squared. So we can't add those together either, but we are going to write them kind of going from highest to lowest, which means the x cubed will be written first. So I'm going to write 4x cubed y squared, and then the x squared part, minus 5x squared y cubed. So in this particular instance, we were told to simplify, but we could not actually combine anything together because we don't have any like terms. So what we do is we are just kind of rewriting it, trying to go from the highest degree to the lowest degree. So that way we just have it in a standard form. So sometimes you'll be told to simplify, and there's not really anything you can do other than just rearrange it to follow conventions. So now I'm going to move to the one on the right. And because, again, I have a subtraction there, I'm going to write it as plus a negative 1. And then I'm also going to do that. Well, I don't need to do it in the parentheses because I don't really need a plus sign in front of there because that's the first term. So I could ignore the parentheses in the first polynomial because there's no number in front. And then I'm going to write plus negative 1. And then I have negative 6x to the 5th plus 2xy cubed plus 4x to the 4th y. So I need to distribute the negative 1 through before I can start combining things. So I need to multiply the negative 1 by everything in the parentheses. So everything in the parentheses is going to change sign there. So I have to multiply it 3 times. And the first things are not changing. So I have a negative 1 times a negative 6, which cancels, gives me a positive 6. So I get plus 6x to the 5th. Then I have a negative 1 times a 2, so that's a negative 2xy cubed. And then a negative 1 times a positive 4 is a negative 4x fourth to the y. So I've done the multiplication. Now we want to combine like terms, and we generally want highest degree first. So I'm going to write down the degree of each term. So 10x squared is degree 2, because it just has one variable, so it's just literally the exponent. The minus 14x to the 4th y is degree 5, and it's degree 5 because that y without an exponent is considered a 1. So 4 plus 1 gives you 5. Make that a better looking 5. That's not a better looking 5. I just lost my y. Erased too much. There we go. Next, 6x to the 5th, so that is also degree 5. Then I have minus 2xy cubed, so that x is considered degree 1. So this whole thing will be a degree 4 because it's 1 plus 3. And then I have minus 4x to the 4th y. The y is considered a 1, so that's going to be degree 5. So when I start combining my like terms, I'm going to start with all the degree 5s and look for what are like terms, and then work my way down. So I have 3 things that are degree 5, and I want the one that has the highest thing on x, so the x to the 5th. That doesn't match with anything else. I don't have anything else that's x to the 5th, so I'm going to start with 6x to the 5th. Now I'm going to go to the other things that are degree 5. I have a minus 14x to the 4th y and a negative 4x to the 4th y. Those are like terms. They match in variables and the exponents. So I'm going to highlight these. So we actually do have some things that we can combine here. So I have a negative 14, and then I'm subtracting 4. So that's going to be negative 18. So this would be minus 18x to the 4th y. Again, the variables don't change. You're not doing anything with that. You're just combining the numbers. So that's taking care of all of the 5th terms. And if this gets confusing for you, you can kind of, some people, they'll cross them out so they know what they've taken care of, so they don't get confused. So you can do that so you can see, okay, what do I have left that I need to kind of put together? So we got through everything that's x to the 5th, or that has a 5 degree, the 5th degree. So now the next one is degree 4, which is our minus 2xy cubed. There's nothing else that matches that, so I'm going to just write it down. And then just to be safe, cross that out. And then the only thing I have left is the 10x squared. There's nothing to add it to, so that's going to be plus 10x squared. And since that's the last term, then I'm going to put that in the box, and now we have simplified. Are there any questions? Okay. How are you guys feeling with this so far? Because this is taking longer. I'm only halfway through my slides and it's already been 45 minutes. So how are you guys feeling with this, the adding like terms and everything so far? Crickets. Yes, Tim, go ahead.
It's great. It's really helpful. I've been through it, but it gives me more clarity and understanding.
That's good. So because I was thinking, I'm like, I might, if you guys need more examples, I can do those. I'm thinking, because I'm only halfway through my slides, that I might do a second session maybe tomorrow, if that seems okay with you guys, so that you're not sitting here for an hour and a half, because I have so many slides. Yeah, Robin, go ahead. Okay, Robin, if you're speaking, it's okay, there you go.
Okay. Your explanations are spot on. After not being in school for 30 plus years and getting this refresher, it's wonderful the way you explain it. I really appreciate it. Thank you.
Cool. I'm thinking, okay, so I think what I'm going to do is I'm going to actually open up Alex and go in as a student and kind of work through some of the, just kind of show you working through this assignment with the operations for the like next 15 minutes or so, and then I'll do another session. I'll have to look at my schedule to see when people are available tomorrow, or maybe I'll do it like Monday or something like that. But then I'll do the second half, because I don't want to overwhelm you guys with too much going on. But I think kind of working through Alex would probably be to kind of show you this. So I'm going to do that. So I'm going to go into the student view. Okay. So course, because I'm a student, I haven't been doing any of these things. So, okay, so we're looking at the operations on polynomials. This is week 2, number 3. So that's what I've been going through. So it's got 5 questions. So I'm going to start. Okay, so we're kind of starting, like, I'm going to zoom in here, not the right one. There we go. Okay, so might as well just kind of work through it. Of course, you guys are going to have different numbers and everything like that, but determine the degree of the polynomial. So you can see that this is very similar to the polynomials that we just did, where it's got multiple variables. Here we've got 3 variables, but the rules are the same. So they've split up the terms for us. So you can see that that minus 2, that middle term, they're including that negative there. So you're adding the degree, and if there's no exponent, it's going to be degree 1. So I've got a 7 plus 1 plus 2. So that's 7 plus 1 is 8, plus 2 is 10. So that's going to be degree 10. Then here we've got a p, so that's degree 1. So 1 plus 7 is 8, plus 2, that's also degree 10. And then here we've got 4 plus 4 and then plus 1. So we're going to get degree 9. So I'll check. Perfect. Okay. So you can see the homework is kind of walking you through what I just did here. So, or what I was teaching. So the degree of the polynomial is the largest degree. So we've got 2 terms that are degree 10. So our whole polynomial is degree 10. That's the highest number there. Okay, so got that part 2 right. Okay, so here is a subtraction problem. So this is going to be, and it doesn't have the multiple variables, so we can go through here. So what I'm going to do so that I can do some work, let's see. I wish I've got too many screens here. I'm going to switch screens. Hold on a bit. I'm going to switch which screen I'm sharing. Okay, so I'm going to just kind of, I want to be able to, since I can't actually literally show you a piece of paper working out this problem, I'm trying to make it work out so I can use my tablet and work through the problem at the same time. There we go. Okay. So I'm just kind of trying to make things work here. So we've got our problem, we're subtracting a polynomial. So the first one, I don't need those parentheses. So we've got 7x cubed plus 9x plus 5. Now we've got this subtraction, so that's where we're going to rewrite it as plus a negative 1. Hopefully I remember the negative. And then the first negative, I don't have to rewrite that, so I can keep that as negative 7x cubed. But then I have a minus, so let's turn that into plus a negative, so that's negative 9x. And then another minus, so that's plus negative 5. So now I want to distribute, I'm going to multiply that negative 1 through the parentheses. Everything before that is just remaining the same. So I'm a negative 1 times a negative 7. That becomes a positive 7x cubed. Negative 1 times negative 9 is a positive 9. So I have plus 9x. The negative 1 plus negative 5 is positive 5. So now I want to start with the highest exponent, which is 3. So I've got a 7x cubed and another 7x cubed. So those add to 14x cubed. I don't have any x squareds. I've got a 9x plus a 9x, so that's 18x. And then a 5 plus 5 is 10. So if it helps you while you're doing this, you can do the highlighting, or You know, you can say, okay, I added those together. Now I added those together. I can add those together. So now I've got 14x, and then I use keyboard shortcuts. If you hit the shift button and then 6, that will get you up into the exponent. So I usually use those. But then you have to remember to hit the arrow key to get out of the exponent. You don't want to get any mistakes there. Okay, check. And it's so small I can't even see if I got it right or not. Good. All right. Okay, so now here's a multiplication one. So we haven't done multiplication yet, so I'm going to skip that, see if there's any others here we can do. That's multiplication.
The rest are multiplication. I did it today.
Oh, okay. All right, so then I'll save this for later. And then, so you can save it for later. I'm going to go back to the assignments list and just kind of show you the optional assignment. Okay, so I'm going to just type into the search button week 2 so I can find it. Okay, and then optional operations on polynomials. So there should be more if you feel like you need more practice on those. There will be more practice here. So there's more practice on degree and leading coefficient. Make sure it loads so that you can actually see those. So if you feel like you're not fully confident or if you were struggling on those original problems, these are really good to go back and do some additional practice here. So you've got some more. You can see we're here, the direction said to simplify. So I talked about that, how the directions might change. Here's another one that's simplify. This has 3 together, but the rules are the same. So you're doing a subtraction and then you're doing an adding. Another one here. Okay, and then we're getting into multiplication. These should be roughly in order. So the ones from the rest of them should be like multiplication ones. And I did see some people were saying, oh, there's not a lot of help on these kind of things. Just make sure that you are checking these buttons on the right. There's not going to be help on the quizzes, but there is like an explanation. There's an example. There's a link to videos, the ebook. So there are some options here. Not every single one has one that it steps you through. Some of them don't have that step-by-step kind of thing where you can do it like step-by-step, but at least the explanation. And they color code it, which is really nice too. So sort of like the highlighting that I was doing. And then if you're trying to take notes, I've had a few conversations with some people about good note-taking skills. Don't just write the math on the left. Writing down these directions are very important too, so that when you go to your notes, you know what you did. Because if you didn't have these directions, and all you saw with the math, it's kind of hard to see how you went from one step to the next step and what happened. So you have to write down the directions on what you did, so that way you see, oh, this is what we did. And that's how you really learn it. It's by writing down those directions, which when I do these live sessions, it's all verbal. And then what's nice is that there's these little more buttons. So if you weren't sure about something, you can see, oh, that's how that worked. That's why all the signs changed kind of thing. Because they didn't show it the same way that I did it. They just immediately changed the signs. They skipped that -1 step. But the same thing is the output is the same here. They're just showing it a little different. And so if you hit that 1, that's where that -1. So they're not showing that -1 step in the original explanation, but you can see it in more detail. And they're actually showing more detail than I did by actually stepping through the multiplication. So, yeah, I'm going to have to look at my schedule, take a look when people are available tomorrow or later this week so I can do the multiplication part of this. Because there are some techniques that I'm going to show on the multiplication that aren't shown in the textbook. So we'll keep an eye out on your email for that. And if you can't make it, at least there will be recorded. But thank you guys for sticking with me for a whole hour here. So I really appreciate it. I'm glad it's helpful, and hopefully you feel more confident to go back and do some more problems from here.